from tennis the other day. When
Okay.
you fall asleep in the sun, your lips get somewhere bad.
Okay, let's go over chapter 12.
We were watching Caitlin play, and I
Look
fell
at
asleep.
page 461.
She was killing this Chisholm girl. I'm sorry.
Let's go over some of this vocabulary. This to me is a little easier, I think, than what we did like in the last chapter. We did the percentages and stuff, or the ratios and concentrations and all that. But dimensional analysis is what we'll use for this too. So still plugging in, putting everything in your formula plugged in and all that. So 461, it says continuous infusion. Continuous infusion. So this is introduction of a substance such as IV fluids or interstitial fluids over a period of time without the interruption of therapy. So this is like if they're on an IV, for the whole day or something like that. Conversion factor over time. So this factor needed to change from one unit of time to another, which is hours, minutes. So that's one thing that we'll add into this. Like we'll have our dimensional analysis, like our long, problems that we've been working out. But this time we're going to add in time. Like this medicine needs to be given over 30 minutes. So then how many drops per minute do we need? That kind of thing. So that's something else that we'll add in. Dose time, the amount of time needed to administer the medication. So some, like an IV push medication, you usually just push it in through their IV, like using a syringe. No, you don't just like shove it in and be done. It's usually you have to wait like 2 minutes. So you watch your clock and do a little bit at a time over 2 minutes. And that's kind of generally how fast you give medicine. Some you can just push in, some you can't. But IV piggyback medications or other IV medicines are usually given over a period of time. So like maybe they are supposed to get 1 bag of fluid in 8 hours. That's just like a regular kind of maintenance IV therapy. Okay, so they give it over 8 hours and you can figure out how many drops per minute they actually need. Another example is like an antibiotic, for example, like vancomycin is one that has to be given pretty slowly because they get, it's a reaction. I know I looked at it because I saw it on paper. Vancomycin, if you get it too fast, you get this.
Blood clots.
The body turns red. Oh, Redmond syndrome. Yes.
Bet.
Okay, and so if you give vancomycin too fast, they will. Their whole body will just turn red. So it's usually given over at least 2 hours. Sometimes even longer, depending on how sensitive they are to the reaction. So if that's the case, then you want to figure out how many drops per minute they need to give that medicine over 2 hours. Does that make sense? Most antibiotics are usually given over like 30 minutes if you give them IV. But it depends on how much and what it is. Dose volume, this is the volume of medication administered at a given time. The drop factor, this is the size of the drop from the drip chamber found on IV tubing. So let me show you guys what that means. Okay, so when you look at IV tubing, when you look at IV tubing, you got, your big bag of fluid, and this is kind of what a basic IV tubing looks like. Now, depending on if you've got like a pump or something, it'll have special tubing it'll plug into a pump. But this is kind of your basic IV tubing. This has kind of a sharp point on it. This is what you spike into the bag. Okay, and so, right now in here you just have air. So what you do, this clamp This is your drip chamber right here. Okay, and this clamp has, it's just what closes or opens the pressure that allows this to go through. So it just, all it does is just squeeze the tubing shut as you roll it down. So this is what you would put in, you'd spike your bag in here, you squeeze this and it pulls fluid down into this chamber. And then this, where this is on this clamp, this is kind of what controls how fast fluid would drip through here. So let me go get, I'll kind of show you.
Bag of saline.
Bag.
Water.
Okay, so so this is your bag of fluid. The little plastic thing comes off. Now this one right here that has a little rubber stopper in it, this is where you add in medicine. So if I like mix some sterile medication, like if let's say we needed to add potassium to this, or we wanted to add, whatever else we wanted to add to this bag, you could mix it up in a syringe and then you would inject it through here. That's what this port is for.
Do you have to do air with that too?
No, because this is a bag. It's got some room for that. And then this is where you actually use spike with this. So if I'm going to take this and spike it in here, well, let me teach you about the rest of the stuff that's on here. There's usually another clamp, like this little clamp right here, and it just closes the tubing as well. This is for like if you don't want to mess with this, so you don't change the speed of the drip, but you still want to shut off the IV, like make it so it stops going. You can use that clamp. Okay? And then this, of course, is where. And this is where it would just plug into their IV or the tubing or whatever else you have. So, two things. One, I'm going to close this before I get started here. I don't drip water everywhere. And you just take the bag here. Put it in here. Up a little bit. Okay, and then you squeeze this and it's going to fill that drip chamber up. And now this is then what controls this is what controls how fast the drips go. So see, if I open this up, see, it'll go really fast. Okay. So that's like if somebody says, give them a bag of fluid wide open. That means they need it as fast as they can get it. Maybe they're hypovolemic, maybe they, lost a lot of fluids or whatever. But that's how you determine. So this drip factor is what we're talking about. Okay, so that's how fast, and
Nice.
now we have pumps. What'd you say?
Sheep birds or something, I can tell.
So that's how you determine, though, your speed. Now, how I know about the tubing itself is on, where did I put the package?
Right there in the chair.
Oh. So on this package, it's going to tell me how many drops there are for this tubing in every milliliter. So this one says drops per milliliter, there's 15. So that's our drop rate, or our, what do we call it? Our drop factor, okay? That's how many drops it takes for this chamber, this particular tubing, to get to 1 milliliter. It's 15 drops in every milliliter. Okay, so that's another conversion factor that we'll use. But that depends on the tubing. And there are micro tubing, like here, here's another one. This one has this little blue card in here that looks like it, and this yellow, and this means it plugs into a pump. So it would go with a specific type of pump. Let's see what this one says.
So how do you get all the air out of there first before you?
That's called priming it.
I'm
And
sure
so
you know
before
that.
you ever before you ever plug somebody up to this IV, then yes, that's called priming your line. And you just let it run until you don't have any bubbles or air in your line. So I just let it run like into the trash until all my bubbles or the one little bubble in there is not going to hurt anything.
No, it's like a continuous flow.
But yeah, you just want your line full, because if you don't prime your line, it's really important. And I mean, this isn't necessarily a pharmacy technician skill, but if you don't prime this line first, what's going to happen if I plug this into their arm and then go?
It's gonna put like an air bubble.
They're going to get
Body.
all this tubing full of air into their bloodstream, which will kill them. And it's called an air embolism. If I remember the word embolism. Some form in your bloodstream. Now, little bubbles in this tubing are not going to hurt anything. I can't remember. I mean, I've like watched bubbles and I'm like, what's going to happen? But it's, it's not. You're like, I'm watching my death come, but it's not like that. You can have several little bubbles in here and it won't hurt anything. They just get absorbed in your bloodstream. But a whole air embolism is going to fill up a whole blood vessel full of air. And that's not okay. And when that gets to your heart, it's not good. Let me see. I tell you, it tells on here how much. So in this tubing right here, it actually holds 13 milliliters total at any one
It's a
time.
lot of air.
So that is that. I just wanted you to see, kind of get a picture of why we talk about the drip factor and all that. Okay, so it'll make sense. Okay. Okay, flow rate, it says the speed at which IV medications are infused, depending on the physician's order. It's usually in drops per minute. IV is just within the vein, you guys know that. Macro drip infusion sets, these are infusion sets for measuring rate of IV fluids. They usually provide large drops, like 10 to 20 drops per milliliter. Oh, I didn't look at that small IV tube. That's what it said. It must tell inside here. Doesn't say on the outside. Oh, well, this one just doesn't, I guess it's because it's pump heavy. Maintenance therapy says using IV fluids to provide necessary nutrients to meet daily needs for water, electrolytes, and glucose. Like I said, that's kind of like that continuous infusion means that they're getting it all the time. Maintenance therapy is kind of the same idea. It is a continuous infusion, but you just get it if you need potassium or, it's just like your regular. Micro drip infusion sets. These are says used for measuring a rate of IV. They usually supply small drops, like 60 drops per milliliter. So, those drops are going to be a lot smaller. It takes a lot more to get to a milliliter. And these are called micro drops. Other micro drip sets provide 50, 100, or 150 drops per milliliter. That's Piggyback, we've talked about this before, special coupling for primary IV lines to allow supplementary solutions to be added. So you hang up your two bags, whichever one you hang up higher is the one that's kind of going to overpower the other one. So that's why you call it a piggyback. You hang your IV fluids lower, your piggyback, your antibiotic or whatever up a little higher, and because of gravity, that one will go in first, and then your other one will follow behind. Prophylaxis, this says using biological, chemical, or mechanical agent to prevent disease. We've talked about that word before, right? Prophylaxis, you take it to prevent something. Replacement therapy, the process of providing fluids and electrolytes to the body when you have a deficit. Restorative, restoration of vital fluids and electrolytes. Solute, the substance dissolved in a solution, and then solvent is a substance in which it's dissolved. All right, let's go on to 472. It says interpreting amounts of solutes in IV fluids. So it gives you some abbreviations for calling IV fluids at the bottom. We've looked at some of those before. So normal saline is just your normal 0.9% sodium chloride. It's supposed to be isotonic, with your blood. What does that mean?
The same amount of solute, so it doesn't blow up or shrink your cells.
Right. So it should be an equal concentration ratio as your blood. Good. Half normal saline would be half of that. So instead of 0.9%, it's 0.45%. So, and then you can kind of go on from there. You can see what those are. Let's go ahead and just work out some of these practice problems, and I'll just